Hello YouTube, how do you do? In today's video, we are going to take a TryHackMe room, the TryHackMe room that has recently been released. The room is about a privilege escalation technique in Windows operating system. It is not a single technique. In fact, there are two different vulnerabilities. We are going to combine those two different vulnerabilities in order to escalate the privilege to system user in Windows system. And when I was learning this technique for the first time, it was quite fascinating. It taught me a lot of new things. So that's why I'm here, wanted to bring this concept to you as well. And actually this vulnerability recently spotted, not recently, in fact, they spotted this vulnerability in the mid of 2022. Then once they disclosed it to the Microsoft, and they took almost 6 months of time to fix this flaw. And the beginning of this 2023, they have fixed this, and also they finally disclosed the common vulnerability exposure. And once they disclosed, after a few days, they have released the proof of concept too. Well, I'm going to explain the high level stuff, the stuffs that are explained in the TryHackMe room. They have explained this concept with the neat diagrams, neat charts. So I'm going to use that chart to explain the concept. I'm not going to dive deep into that low level stuffs and all, because it's a vast topic. We need a lot of sessions to explore everything. So that's why. So without further ado, let's begin. Now you are looking at the pertaining TryHackMe room. The room title is LocalPotato, and that's what the name they have kept for this vulnerability. Learn how to elevate your privileges on Windows using LocalPotato. And here is the CVE ID that I was talking about. And in order to start this machine, you must be connected to the TryHackMe's network, and you must start the TryHackMe's machine. So they gave all the code, the POC stuff, everything in this machine. So all you need to do is to connect their network and access this machine. I have connected to their machine, and here is their machine. You can see the folder here. So within this tools folder, they kept everything needed to take this exercise. Now let's get into the introduction part. So you will see a lot of theories here. So let me admit that, but it will be quite fascinating. So if you focus this, you will be learning some new stuffs, that's for sure. Well, the introduction. A local privilege escalation vulnerability in Windows was reported to Microsoft on. So this is about the date and time when they have reported and who reported this flaw. The vulnerability would allow attacker with a low privilege account on a host to read and write arbitrary files with system privileges. The LocalPotato vulnerability itself to write the files arbitrarily on system. So we need to combine this file writing vulnerability with something else to escalate the privilege, to execute the command as system user. So I'll explain what vulnerability that is. So bear with me. So Microsoft released a fix for the vulnerability in Jan 2023 patch Tuesday. A working POC was later released on February 10th. Well, while the vulnerability is in itself wouldn't directly allow executing commands as system, we combine it with several vectors to achieve this result. And that's the important point. This vulnerability itself don't allow us to execute the command. Instead, we are going to combine this vulnerability with something else to get that command execution privilege. Conveniently, on February 13, another privilege escalation POC was published by Black Arrow Sec. So here is the Twitter link. If you see the left bottom, you can witness the Twitter link that abuses the StorSvc service, allowing an attacker to execute code as system as long as they can write DLL file to directory in the path. Well, in this specific second vulnerability, they are actually leveraging this StorSvc service, and it allows the attacker to execute the code as system as long as they are able to write a DLL file into the system privilege directory, the C drive or system 32 drive, the familiar one, or it could be something else, a privilege directory, the directory that is controlled by the system, the administrator of Windows. In this room, we will look at both vulnerabilities and combine them to get arbitrary execution as the system user. Well, it is about both this vulnerability, not only this LocalPotato. Well, this is a guide to start the VM. We have done that already. Now, if you want to understand this LocalPotato vulnerability first, you need to understand the NTLM authentication. Even I was not familiar before I learned this. but they explained this higher level how the authentication happens. If you want to learn this NTLM authentication low level clearly, maybe you can try to intercept an NTLM traffic, and you can in Wireshark, and you can go through that packet capture every packet one by one. So it will be giving you the clear picture of that NTLM authentication. So what are all the parameters involved in every handshake of the authentication. So you'll be able to learn that. Well, and look at this one, look at the high level stuff. There are three messages, and they are calling all three messages as type 1, type 2, and type 3. The usual case of NTLM authentication involves a user trying to authenticate remote server. So this is a remote NTLM authentication. So there are two types in the NTLM authentication. One is local NTLM authentication, another one is remote NTLM authentication. Obviously, if user trying to authenticate the external device, a remote device through NTLM, it is remote. If they are trying to authenticate a service or something else within the system, then that is local NTLM authentication. So that's the difference. And three packets are involved in this authentication process. Type 1 message. So let's see what sort of contents present in this type 1 message. The client sends a packet to negotiate the terms of authentication process, and the packet optionally contains the name of the client, machine, and its domain. The server receives the packet and can check the authentication was started from different machine. Well, it's a simple one. First of all, typically the client initiates the traffic, because the client wants to authenticate. So it initiates the traffic, and it actually keeps its machine name and also its domain detail in that packet, and it sends the request to the server. Once the server receives, it validates that domain and the machine detail, and it actually it is getting ready to send the type 2 message. The server responds to the client with challenge. So here the concept is the challenge. The type 2 message contains a challenge. The server actually challenges client to do something. The challenge is random number used to authenticate the client without having passed their credentials through the network. Passing the credential through the network is always a dangerous thing. So to avoid that, they are actually doing a thing called challenge, and they are using a random number for that. So the server does send a random number as a challenge, and used to authenticate the client without having to pass their credentials, as I said. Well, let's see what the client does for that specific challenge. The client uses the challenge received on type 2 message and combines it with user's password hash generated, and I mean to generate response to the challenge. So actually the client getting ready to respond to the challenge, and it actually receives that random number. It actually the client has the password hash, right? So it combines that password hash with that specific random number sent by the server, and it actually combines those two details and responds to this responds to the server as type 3 message. And that's what they gave here in this type 1, type 2, type 3 authentication stuff. They clearly explained it in the image. So here is the client, here is the server, type 1 negotiation, type 2 challenge, and type 3 response to that challenge. And that way server can check if the client knows the correct user's password hash without transferring it through the network. So it's a good it's a good method to validate the password of the client. Well, now we have seen the NTLM remote authentication, simply NTLM authentication. Now we are going to look what is NTLM local authentication. So here two different devices, PC0 and PC1, but here both are same, PC1 and PC1. Both devices are same. It is actually happening internally. Now let's read through this. NTLM local authentication is used when a user try to log into service running on the same machine. So it could be service or it could be something else. When the user try to log into the service that is running on the same machine, then it might be using the NTLM authentication. Well, since both client and server applications reside on the same machine, there is no need for the challenge response process. So it is scraping this process. Instead, it is using different thing. Authentication is instead performed differently by setting up security context. So here the term is security context. Earlier it was challenge. While we won't dive into the details of what is contained in the security context, As I said, that's the low level stuff. If you want to learn, you can intercept NTLM authentication stuff and you can try to learn that. Think of it as set of security parameters associated with connection. So what they are trying, they are defining this security context as a set of security parameters associated with the connection. So you can simply keep like that in your mind, including the session key and the user whose privileges will be used for authentication. So it also contains the session key and also the user's privilege. Well, let's see this image. Here I can see the client application and the server application. It is actually sending the type 1 message. They are calling it as a negotiation message, as they have called in this remote NTLM authentication. So it actually sends the workstation and the domain details. So type 1 message is same, I suppose. But when the type 2 message sent by the server, it actually prepares the context ID. As they have mentioned, the context ID contains the security parameters associated with the connection. It could be a session key, user privilege, or whatever, or something else. Now let's read through this one. The client sends this message to start the connection. It is used to negotiate the authentication parameter just like before, but it also contains the name of the client machine and its domain. The same thing. The server can check the client's name and domain. Local authentication process begins if they matches their own. In this type 1 negotiation, it sends the workstation name and the domain name. So it has to be same as the server, the server applications machine. So nothing but the same machine. So if it matches, then it actually proceeds with that local NTLM authentication. The server creates security context and sends back to its ID to the client this message. And the client can use this security context ID to associate itself with the connection. Well, once the server, the same machine, once the server app supplied that context ID, the client apps uses that client ID with that, with its conversation, just as an identity. In type 3 message, if you read, you will be understand. You can understand. If you client, if the client successfully associate themselves with the existing security context ID, an empty type 3 message is sent back to the server to signal the local authentication process is succeeded. Typically, the type 3 message would be empty. If it sends the empty message, then the server can assume the NTLM authentication is succeeded. Well, that is the both local and remote NTLM authentication stuff. Since all steps occur on the same machine, there is no need to follow the challenge response method as we did before. The machine can validate security context ID for both server and client applications. Well, here everything is the context ID. So this is the crown jewel of this authentication stuff. Well, we try to understand this with the help of two diagrams, just higher level. Let's move on to the next one. Now we are getting into that actual LocalPotato vulnerability. So what this LocalPotato vulnerability is all about. So let's get into that. LocalPotato. The LocalPotato POC takes advantage of flaw in a special case of NTLM authentication called NTLM local authentication to trick a privileged process into authenticating a session the attacker starts against local SMB server. I hope you understand this line. Here, what they are trying to say, in this LocalPotato, they are leveraging this NTLM local authentication. So they choose a privileged process and they try to trick that privileged process into authenticate a separate session that is actually initiated by the attacker to some service. It could be SMB or whatever. And as a result, the attacker ends up having connection that grants him access to any shares with privileges of the tricked process. Here, hence they are trying to access the SMB server. It could be leading to the top privileged share access, which means it could lead to the full access of C drive and the admin $drive. Well, I'm scrolling down. Let's try to see this diagram once before reading through this one. So here is the diagram and the PC, the machine is same because this LocalPotato is happening in the local NTLM authentication. And here is the privileged client and the privileged process. The privileged client and the SNMP server. So the attacker tried to trick this privileged process. So what they are doing, they are deploying they are acting as a man in the middle between this privileged client and the SMB server, and they are deploying an attacker server and one attacker client. So what they are doing, the type 1, type 2, type 3 messages are same. First of all, it shares the workstation and the domain details. and actually this the privileged client supposed to share it to the SMB server, but the attacker acting as a man in the middle and collects that request from this privileged client. So once it collected that, it has that context ID. Now without responding to this privileged client, the attacker client initiates a session to the SMB server. The SMB server is supposed to be connected by this privileged client. So once the the other attacker client initiated that type 1 message, the SMB server actually shares the context B. Actually, this is the privileged context, I suppose. So it shares this context. So once the attacker client got this uh, uh, context from the SMB server, it actually swaps that context. Now, what will happen? All right. I'll try to explain this local potato privilege escalation, this interception process vividly. Now, look at this one. You have to understand this architecture first. The privileged client, which means the privileged process, trying to access the SMB server, and within the same machine it is happening. And the attacker is acting as a man in the middle, creates attacker server and attacker client. Well, once this privileged process, the privileged client, try to access this SMB server, it intercepts that request with its attacker server, and it got that type 1 message. It contains workstation and the domain name of the machine, and it actually gets that, and it produced the context EA, okay, for this workstation and domain name. Well, it keeps that context EA. Now the attacker client initiates a request to the SMB server. Well, it uses the workstation and the domain name. It gets the context ID B for that from the SMB server. Now what it does, it got context ID A from privileged client, context ID B from the SMB server. Now the attacker server and client has both context ID A and context ID B. Now it exchanges this context ID, it swaps it. So once it's swapped, what happens? Let's see that. First of all, this context ID B, that is received from this SMB server, it actually swapped with context ID A. Now the context ID B is sent to the privileged client. The context ID B is actually shared by the SMB server. You can see it here. So it is generated here. Now it is shared to the privileged client. Once this privileged client receives this context ID B, it understands, okay, this one is received from this SMB server, and it responds that empty type 3 authentication. Once the this indicates the authentication is succeeded. So once it got this, it sends this type 3 authentication message. The attacker server receives the type 3 empty authentication. The authentication is successful. So once it receives, what it does, it actually gives this to this attacker client. Now the attacker client is having the full privilege to access this SMB server. Now what it does, it forwards that empty type 3 authentication to SMB server that actually received from this privileged client. Now the attacker client would be having the top privilege, the system privilege to modify anything on this SMB server. And that's what this vulnerability is all about. And the same stuff they gave here in this three paragraphs. Now let me read through this one. By having a privileged connection to SMB shares, the attacker can read, write file to the target machine in any location, and that's the biggest advantage. This flaw just allows us to write any files. It is not yet allowing us to execute the command as system user. While this won't allow us to run commands directly against the vulnerable machine, we will combine this with different attack vector to achieve that specific end. Note that the vulnerability is in NTLM protocol rather than the SMB server. So this same attack vector could be theoretically used against any service that leverages authentication through NTLM. And this is a very important thing. Now in this case, it is actually the SMB server is actually using the NTLM authentication. So we leveraged the flaw in this NTLM authentication, and we got access to SMB server. Instead of this SMB server, it could be anything. It could be any other service that uses the NTLM authentication. So if it uses this vulnerable NTLM protocol, then you would be able to explore, or you'll be able to exploit any service that is running it. Well, that is the thing they are trying to explain. In practice, however, some caveats must be dealt with when selecting the protocol to attack. The POC uses the SMB server to avoid some extra protections in place for other protocols against similar attack vectors. Even implementations quick. Okay, they gave a reason for not using the other protocol. Why they chose SMB? Because they said there were some other vectors, attack vectors involved in other protocols. So that's why they chose this one. All right, this was a total theory, but this diagram explains the whole story. If you understand this diagram, then you can be pretty much okay with this high level local potato understanding. Well, if you want to learn more about this local potato vulnerability, how it really happened, how it really vulnerable, then here is the link to the original local potato disclosure. And if you read through this one, you will be able to understand the low level stuff. And look at the screenshot. They have actually intercepted NTLM authentication message, and you can see they actually inspected various fields present in that message, and they finally found that bug, and they leveraged it. And look at this one. In this graph, they try to explain how it exactly happens. Well, it's a lengthy blog. If you get time, you can feel free to go through this. I gone through this blog already. I was able to understand few things, and many things I was not able to understand. And you can try to refer this one if you get the time. Well, with this diagram, we try to understand this. We tried to understand this local potato. Now moving to the next one, we got a way to write any files on the system now by leveraging local potato. Now the next thing is abusing StorSvc to execute command. So this is the second vulnerability, and we are going to combine this both local potato and the StorSvc abuse to escalate the privilege on the Windows machine. Now let's try to read through this. So far, we have used local potato to write arbitrary files to the target machine. To get privileged shell, we still need to figure out how to use arbitrary right to run a command. Recently, another privilege escalation vector was found where the attacker could hijack missing DLL to run arbitrary commands with system privileges. The only problem with this vector was that an attacker would need to write DLL into system's path to trigger it, and that was the constraint. By default, this vulnerability, if you have this vulnerability alone in that system, you cannot escalate the privilege on the system, because you need to find a way to write the DLL file, your DLL file, into any of the high privileged directory like system32. But since we are combining these two, this local potato is going to help us to write that DLL into that privileged path. And by default, Windows path will only include directories that only privileged accounts can write. While it might be possible to find machines where installation of specific applications has altered the path variable and made the machine vulnerable, the attack vector only applies to particular scenarios. Combining this attack to local potato allows us to overcome this restriction and have fully working privilege escalation exploit. Well, both these techniques need each other to escalate the privilege in the system. So any one technique, by using any one of the techniques, we cannot achieve this privilege escalation, and that's the main thing. StorSvc and DLL hijacking. Now let's try to understand this vulnerability. And here they gave another diagram. Before that, let's read through this. As discovered by Black Arrow Sec, an attacker can send RPC call, remote procedure call, I guess. So let me get the help of ChatGPT to understand what is RPC call. Here it's taking some time to load, but let me read through this one. As discovered by Black Arrow Sec, an attacker can send RPC call to SVC reboot to flashing mode. I'll explain what it is. Provided by StorSvc service, which in turn will end up triggering an attempt to load missing DLL called print.csp.dll. Well, I think now it is loaded. Yeah. Now let me RPC call in Windows. What is RPC? So let's try to understand what is RPC now. RPC is remote procedure call, I guess. So that is the definition. It is taking a while. Meanwhile, let's read through this one. Now the attacker is here. Attacker is actually triggering an RPC call to SVC reboot to flashing mode. It's a method actually. It's a method that belongs to this StorSvc service. Actually, the attacker tried to send the RPC call to this method. So once it receives the RPC call, this service is running with the system privilege. So what it does, it tries to load the missing DLL from path. The missing DLL name is sprint.csp.dll. Now, if we are able to provide this missing DLL, then if we contain, I mean, if we keep some malicious stuff within this print CSP DLL, then we'll be able to execute that. I mean, we will be able to achieve that malicious stuff that we have mentioned in this file. So that is what the thing. Now let's see. RPC, remote procedure call, is a technology used in Windows operating system that allows a program running on one computer to invoke subroutine or function on another computer on the same network without the programmer having to worry about the underlying details of the communication protocol. To make an RPC call in Windows, the calling program sends request to the RPC runtime, which then sends the request to the appropriate server on the remote computer. The server process executes the request procedure and sends the results back to the calling program. Well, it's a quite deep thing. I don't get the whole thing at the moment, but I'll try to understand this one maybe in the upcoming days. Now, for now, you just try to see this diagram and understand what we exactly need to do. We need to supply this print csp.dll, and also we need to find a way to send this RPC call to this specific method. And if you are not familiar with RPC, and that's what I already gave the explanation to RPC with the help of ChatGPT. In this case, StorSvc service exposes the SVC reboot to flashing mode method, which anyone with access to the machine can call. Well, let's try to understand this SVC reboot to flashing mode, what it is. And I already queried ChatGPT to get the results for that. I said, okay, SVC reboot to flashing mode is function or method name that appears to be related to StorSvc service. Well, fine. The term flashing mode generally refers to the mode that allows firmware or software to be updated or flashed onto the device. Therefore, SVC reboot to flashing mode is in StorSvc likely refers to a function within the StorSvc service that reboots a device into mode that allows the firmware to be updated on or flashed onto it. So looks like it's an inbuilt function of the StorSvc, and it uses to reboot the device into the, I mean, that reboots the device into the mode that allows the firmware to be updated or flashed onto it. So it is related to some firmware flashing or something. So this is the thing. Now, since SVC store runs with system privileges, they clearly gave here, creating sprint csp.dll somewhere in the path will get loaded whenever it calls this one is made. Compiling the exploit. Now what we need to do? We need to do a couple of things. We got access to this TryHackMe machine. So here they gave what we need to do. So once we did all these things, we are ready to escalate the privilege, I suppose. Now let's try to do all these things. First of all, we need to prepare this print csp.dll. This DLL file we need to prepare, right? So this is the missing DLL we are going to hijack. The default code provided with the exploit will run the whoami command, and the output responds to this specific thing. We need to change the command to run the reverse shell. Well, here is the first step. In this machine, they gave that sprint csp.dll source code, so we need to do some modification before we are compiling it. And the next one, rpc client.exe. This program will trigger the RPC call to SVC reboot to flashing mode. Depending on the Windows version you are targeting, you may need to edit the exploits code a bit. In different Windows version, different interface ID. Okay, so we need to do some modification. So let's see what we need to do exactly. First of all, we need to move to this path, tools, and the specific LPE path RPC client, and we need to open this specific C program. So let's try to do that. I'm getting into this tools directory, and it contains the local privilege escalation via StorSvc. RPC client is what we need to open, and here is another RPC client folder, and I'm maximizing this. And look at this one, StorSvc.c. This is what we need to open. The default application to open this file is the Notepad++. I'm using the same to open it. Well, we got the file now. First of all, I mean, the only thing we need to modify is this device type. Now they chose Windows 10 here, but first of all, we need to understand on what device we are currently on. So let me try to find this device. I'm opening this system property. So it is Windows Server 2019. Well, we need to enable this Windows Server 2019. So I'm just commenting out this one and enabling this Windows Server 2019. I think that's what we need to do. Now I enable this Windows Server 2019. I am ready to do the compilation. This will set the exploit to use the correct RPC interface identifier for Windows 2019. Now that the code has been corrected, let's open the developer's command prompt. Using the shortcut on the desktop, we will build the project by running the following commands. Simply, we are using the ms build to build that executable. Now, if you want to go through this entire executable, I mean this code, then you can refer this one and you can try to understand how this RPC client really sends request to that specific method of StorSvc service. This is the method. Well, now we need not to read through all these things. So it is there are too many things in this. So I'm just skipping that. So let me open that developer command prompt that they gave on this desktop. So I'm opening it. I'm ready. I have opened it. Now let me maximize this. The letters are too small, so I'm keeping it in the medium, and the size is 24. So now it will maximize the letter. Now it is better. Now let me open into this specific folder, C tools LPE via StorSvc. Well, let me check the present working directory. I think I need to go back. All right, now I'm using the dir command. I'm in the command prompt, that's why I'm using this. And tools, I suppose tools I need to open, and here I need to open the LPE. Well, this LPE via StorSvc contains various things. RPC client is what we need to open, RPC client, and here I got the file rpc client.sln, and I got this file. I'm calling the ms build binary and copying this RPC client stuff. Now it is actually building that binary. So here it is, the process began. So it will take few seconds to build the binary. Meanwhile, let's read through this one. So once it is done, you'll be seeing this one, the build succeeded and the number of warnings and the number of errors. And once it is done, we will be able to see a path called x64 debug. Within that, we will be witnessing this RPC client.exe. So we need to move this specific binary into desktop just to do it easily. Now look at this one, the build succeeded. And let me list the directories, and here is the x64. So I'm getting into the x64, and here I'm again giving the dir, and here is the debug directory, and it should be having that binary rpc client.exe. Yes, it is. Now I am moving this rpc client.exe binary to the desktop, and the desktop path is c users user desktop. So let me move this to this path. Yeah, I think it is good. So it will be moved. Let me add this one. Yeah, now the file is moved. And if I go to the desktop, I'd be able to see this rpc client.exe. Yes, it is there. All right, I got this one. And the next one is I need to prepare this print csp.dll, and we only need to modify the do stuff thing here in this function. And they are asking us to, they are expecting us to modify the specific stuff in that code, and the code is present in this path. Main.c is the code name. And if you once you get into this, then you need to modify this cmd net local group administrator user add. So what they are doing, they are they already wrote the specific DLL code. They wrote in the C program, and in the C program this specific function does that code execution, and you can see the code it actually tried to execute. So this is the code we need to replace, and replaced with. So this one is the CMD, and it is actually executing the command net local group administrator user add. So what they are trying to do, by executing this command, I'm trying to add myself into the administrators group. So once if I'm able to add myself into the administrators group, I'm an admin user, right? So that is what the concept. So let me open this one. I'm going to this specific LPE via StorSvc print csp main.c. So this is the file, and here is the do stuff. So here I need to modify this specific code. So I actually got this one. I'm simply taking this one and replacing it with this command. This is correct. Yeah, now I have replaced it, and also I have saved this main function. In the same manner, I need to build this specific sprint CSP DLL. So let's try to compile that. And here I'm all right. Let me open that sprint CSP stuff. Sprint CSP. Again, once again, the sprint CSP. And here it contains that main.c. I think I need to go one step backward. And here is that SLN file. So I need to build that specific file. ms build this one. So now it is building that binary. Eventually it will be giving us the binary that we need. So we'll be getting 6 warnings at the end of this. I'm copying this one just to do that pasting stuff. Yeah, 6 warnings and the build process is done. Well, let me list this, and here is the directory x64, and I would be getting another directory debug. Yeah, and here is the sprint csp.dll. So I need to move that sprint dsp.dll. I'm moving it to this. Okay, I copied this twice. I need to mention the file name as well. Okay, now the file is moved. I'm going to desktop to witness both the files, the presence of both files. And here is the sprint CSP DLL and the RPC client. So now we have built both executable and the DLL file. The executable to trigger the RPC request, and RPC, and the DLL to present it to the DLL hijacking stuff. Now it is done. We are ready to start the exploitation. Now let's move on to this one. The privilege escalation is very simple. Now we are ready to launch the exploit because we are already having this LocalPotato.txt. It's a pre-built binary already present here. LocalPotato, we haven't prepared this binary because they have already prepared this by seeing the POC that was published on GitHub, and we also prepared this RPC client and sprint csp.dll files. Now it is very simple. Now you need to open the command prompt, and you need to ensure that you are not part of the administrated user because you are a normal user for now. And to successfully exploit the StorSvc, we need to copy the sprint csp to any directory in the current path. We can verify the path in the following directory. Okay, now as I said, we need to copy this sprint csp.dll or whatever, any DLL file into a privileged path. Then only we can achieve this command execution, by leveraging this StorSvc. So in order to write this sprint csp.dll, if we try to move this file from desktop to system32 directory, for example, you will not be able to move because you don't have the privilege. Let me show that to you. I'm opening this command prompt, and here I have opened this command prompt. Now let me maximize this one, this font. It is too small. I couldn't see the letters clearly. Hope you too. Now it is better. And here I am opening the desktop, and when I open the desktop, I'll be able to see all the files that I need to launch this one. And here I need to ensure this the privilege that I'm currently having. I'm simply using net user because the user is I am the user now, and you can see the groups that I'm present: remote desktop users, and I'm not the administrator now. Well, now I'm a normal user, and as a normal user I try to write a file, copy a file to system32 directory, and before that I need to find the list of directories that I can paste. So I'm just querying the specific Windows registry path. So let's see, it will be giving the path that I need. Now let me take this one, system root system32. This path is nothing but the system32 path. So I'm going here and I'm pasting this and entering. Now it is bringing us to Windows system32 directory. Now when I try to copy this DLL file to this path, I won't be able to copy because I am a normal user now. So let me try that. print csp.dll. I copy that and I'm going to the system32 directory. Here I'm trying to paste it here. You need to provide the administrator permission to copy this folder. So we need the administrator privilege. It is not allowing us to copy. And this is where the local potato thing comes in, because the local potato we have already seen, by leveraging the NTLM protocol flaw, we are able to write any file on any location on the Windows system. Well, we are going to use this local potato stuff to write the file now. Well, let me try the same, that the copying action. Earlier I tried it, I was not able to do because of that privilege stuff. Yeah, the access is denied. So now I'm actually using this local potato and calling -i and mentioning this DLL and -o and mentioning this path. So I'm not tweaking this command, I'm just copying this command and pasting there, because when I was trying, I added this C colon in front of this path, it was not working. Now that's why I'm simply copying this and pasting this here. Now let me add this C colon. It will not copy anything. Yeah, it is not actually working. Now let me remove that C colon and I'm simply using local potato.exe in order to copy this print csp into the system32 directory. Now let me click this. Now it is copying. Look at this one, it gave the message, which means it actually copied that file. Now let me search for that specific print file. I am copying this one and I try to search it in the system32 directory. I'll be able to see the file. Look at this one, it actually copied to system32.dll. Now we copied this by leveraging this local potato. Now we are ready to trigger the DLL hijacking stuff, and for that we are simply calling this rpc client.exe. All you need to do is to call this rpc client.exe. So let me do that. I'm simply calling this one and that's it. If I execute this, then that DLL hijacking will be happening at the back end, and it executes that sprint DLL CSP DLL, and we have added the command in the we have added the command within the DLL. The command is nothing but the net local group administrator user add. So this command will be executed as a system user. So we'll be getting the system privilege eventually. So let's try to verify that. I already kept it ready. So when I execute this, look at this one, the message at the bottom, DLL hijack triggered. Now it is done. Now let me ensure that I got that administrator privilege, net user, and look at this one. Now I am part of the administrator group because I have escalated the privilege. Now I'll be able to execute any command I want. And look at this one. If I scroll down, and here I can verify that password 123 is the password. This is the user's password. Now I try to close this one, this command prompt. Let me open the command prompt as an administrator. I'm a normal user. I escalated the privilege now. Now let me right clicking this and try to run this as an administrator. And here it is asking for the password. I'm taking more choices, choosing the user. The password is capital P password 123 and I'm clicking yes. So it will be giving us the system32 prompt. So this is the top privileged prompt in Windows system. And when I try to read who am I can see I am a normal user, but I got the privilege escalated. And this is what. So once we actually elevated the privilege, I'm trying to read this flag file which is present in the administrator's desktop, and I got the flag also, and here is the flag. Let me paste it here and done. Now moving to the next one. So far we have seen the red team stuff. We tried to escalate the privilege by leveraging two vulnerabilities, local potato and abusing StorSvc and triggering the DLL hijacking. Now the detection and mitigation part. So as a blue teamer, this part is very important. You need to be having an idea how this specific exploitation works. Then only you can write an efficient detection rule. And you can see they gave a couple of rules. One is Yara rule to spot that local potato binary, which we have seen in the desktop of the machine. So they wrote the Yara rule to detect the file, and also a couple of Sigma rules to detect the local potato execution, and also the StorSvc print CSP DLL hijacking, because these two activities to be conducted in order to escalate the privilege, right? So they have mentioned everything in this Sigma rule, the important things in this Sigma rule. And once this local potato is activity is happening, then it will be when these parameters are matched, then it will be triggering the alert. Likewise, you can see the list of DLL names. So this one is to detect the DLLs that are created in the system32 directory, the DLLs that are not default to that system. Any new DLLs created and added to system32, then it will be triggering the alert. And this rule is for that one. And this is done. We have seen the Sigma and Yara rules to detect this activity, and they also gave a couple more advices, like patch update the patches as soon as possible if you haven't done that, to mitigate this one. And also the least privilege principle they are advising, like you need to ensure the user is having restricted privilege to that machine that they are accessing. The privilege only the sufficient privilege to be given to any user. So that is the advice. And you can use any SIEM or EDR solutions to monitor the suspicious activity. That is another thing. Well, with this detection stuff is done. And if you want to understand, if you want to learn this POC of both local potato and this local privilege escalation via StorSvc, here they gave both the GitHub repositories, and you can open these repositories and you can go through the source code involved in this exploits. Well, yeah, with this we have accomplished this Windows local privilege escalation. And yeah, this is what I exactly wanted to showcase. Initially, we have seen the local potato vulnerability, how that local NTLM authentication protocol was vulnerable, and we found a POC to leverage that, and there was a pre-built executable file. By using that, we managed to write files arbitrarily on any place on the system, including the admin and the C drive. So once we got that arbitrary file write privilege, we used that privilege to create the DLL of our own, and we managed to use that StorSvc service to trigger the DLL hijacking, and eventually it led us to that system privileged shell. And it was quite fascinating. I hope you really enjoyed this session. If you really did, consider doing all that YouTube algorithm stuff, like, comment, subscribe, everything, and press the bell to get notified. I'll catch you next time with another exciting topic. Until then, I'm signing off. Cheers, and I love you all. Thank you so much.